Hello, hello. Hi guys, starting to see some familiar faces, getting to know folks. We have a do now on a Padlet here. So I want you to think about this question in two ways. Think to yourself and then add it to the Padlet. How do you respond when someone says, I'm not a math person? Or if that's you, if you're someone who says, I'm not a math person, how might you think about today's session from a math lens? So go ahead and add your thoughts to the Padlet. Let's see what creative responses we have in there.
Could you put the link to the Padlet in there? Oh, thank you. You might see it.
Yeah, we'll keep putting it in as people join. Thank you for the reminder. All right, welcome. We just had a few more folks join. We will put the Padlet in one more time for you to see. And the question is on the board. How would you respond to someone who says, oh, I'm not a math person? Or if you've ever been the one saying that, how can you frame your thinking about this?
I love this. Everyone is a math person. One of the responses, correct. We're hearing that echoed. It is just the experiences you have had that have created that feeling. Ooh, we're seeing some great stuff. Everyone sees math differently. I hope to see how you see it. I wasn't either. Why would you say that? Lori asks.
We just had 4 more people join. So for you guys, we are in this Padlet and we are adding our thoughts and our responses. If someone says to you, I'm just not a math person, how do you respond in those situations? Getting some really good responses from the group.
You practice math just like a sport or musical instrument. There is no such thing as a math brain. I love that. Thank you.
All right, wrap up. Let's give it about 30 more seconds. Look at your favorite responses there. You can actually rate them. You can give them 5 stars or 4 stars. So rate some of the other folks' responses, give them some positive affirmation if you really liked one of their responses. And I know that this was helpful for me in terms of thinking about how we talk about math, and to start a PD where we're going to spend 2 hours focused on this topic. It's grounded me and my mindset. So thank you for your wonderful responses there. Today, we are focusing on strong math instruction and tools and strategies from TNTP so that you can promote strong math instruction, observe, and give feedback around strong math instruction. Again, this is our team. Today, you will have Sharon and myself presenting. We have been together for a few weeks, so I'll go quickly through the norms. Participate in the chat, come off mute if you want, and definitely we will have breakout rooms. That seems to be a favorite in the Nebraska group, giving you guys time to talk and collaborate. So we will make sure we build that in. This is a 2-hour session, so we're going until 5:30. Again, we are on session 6 of 8. So we have focused on diagnostics and essential skills and adapting those scope and sequences. And today we will be honing in on math instruction, similarly to Monday's deep dive into ELA instruction. So today we'll be focused on math. We will do some slides you may have seen if you were on Monday at the beginning. So just a warning, there's about 15 minutes that will look similar because we know some people are either coming to the math or ELA session. If you're coming to both, you might get that beginning framing twice. And then we'll wrap up our time together with 2 final sessions around professional development and then planning for strong systems. So today, our meaty question is, how do I know whether students have access to strong math instruction? How can you, in your role, be sure that your students have the best quality materials and instruction in front of them? And with that, I'll turn it over to Sharon.
Hello, everyone. So we are going to ground today's focus on high quality math instruction, and that's just a part of our work around acceleration. And that dovetails nicely with Nebraska's framework for school renewal and specifically core action 1. We want to make sure that the next few slides, as we're reviewing the opportunity myth, we focused with an English lens last time, but the same findings hold true in math. So in 2018, TNTP published the opportunity myth, and it was our 6th report. We came to it, like we have many others, through our work with our partners and our clients. Over the past couple years, we've been helping folks with making the transition to more rigorous state standards. And while people are working and reporting that they're working hard to make the shifts, our reviews of more than 2,700 classrooms around the country have found that 2 in 3 classroom assignments are not rigorous enough to prepare students for college. And 3 in 4 teachers aren't yet adapting the way they need to teach to meet these high academic standards. And so we began to wonder how students were experiencing this gap, and we decided to ask them. We designed a research study that allowed us to study 5 districts, 3 urban, 1 rural, and 1 central management office. And we followed almost 4,000 students and their teachers across the 2016-2017 school year. At the heart of this report are real students, their aspirations and dreams, and how school sets them up or doesn't to reach their goals. We gathered a significant amount of data to paint a picture of what students were experiencing, studying 4 specific components of students' experiences that we hypothesized would correlate with academic success. In each district, we partnered with kinder through 12th grade teachers who selected 2 of their classes for us to study. In those classes, we gathered almost 5,000 student assignments and more than 20,000 pieces of work on those assignments to measure the quality of assignments students received. We also conducted more than 1,000 hours of full-length observations to determine whether students had access to strong, standards-aligned instruction that made key instructional shifts. We studied student engagement by conducting almost 30,000 in-the-moment student surveys to determine how kids perceived their daily experiences in class. And finally, we collected a teacher survey from every teacher in our study to measure teachers' expectations for their students. Here's what we found. That first, students have big, clear plans for college and career. Most students do what they're asked to do in school, but they are still not ready to succeed after school. Students spend most of their time in school without access to 4 key resources: grade-appropriate assignments, strong instruction, deep engagement, and teachers with high expectations. Students of color, those from low-income families, English language learners, and students with mild to moderate disabilities have even less access to these resources than their peers. Greater access to the 4 resources named above can and does improve student achievement, particularly for students who start the school year behind. And since this coming year, most students will start the school year behind instructionally, it's even more important that we ground ourselves in this information. So on the next slide, you're going to see that after analyzing all that data, we saw evidence that we have been dishonest with students about how well prepared they are to reach the big goals that they have for themselves. When we considered almost 25,000 pieces of student work that we had collected, we graded that work twice. The first time you'll see on the left was when we asked ourselves if kids met the demands of the assignment by earning at least 80% of the points available on the assignment. And we said yes 71% of the time. But then we graded the assignments again. On those exact same assignments, we focused on if they met grade level standards, at least with an 80% accuracy rate. We were only able to say yes 17% of the time. That 54% gap is full of assignments that do not give kids a chance to meet the demands of the standards. That means kids are getting good grades and succeeding on content that is not building the ladder to college success for them. We certainly wouldn't argue that there's no room for remediation for students in their assignments. As we go through this session, you'll note that not every assignment that does not meet our definition of grade appropriate is a bad assignment. But we do believe we've got a fundamental problem when the gap we saw was this big, because it means kids are constantly doing what they're being asked to do, but not meeting the demands of the standards. So we're going to look at 2 different examples. All students tended to do what was asked of them and tended to succeed on grade level work. We saw that they were successful across demographic groups: students of color, students from low-income backgrounds, students with IEPs, students who are learning English. In all of those groups, students can and do meet the bar when we give them a chance. In spite of the fact that kids are often getting low quality assignments, when we look just at the assignments that kids gave that gave kids a chance to meet the demands of the standards, we saw that all kids can be successful on grade level assignments when we give them a chance to work on them, which is pretty critical. We also saw that many students never got a chance to try grade level assignments. We collected assignments for 3 weeks during the 2016-2017 school year, and in 4 out of 10 classrooms in our study, serving a majority of students of color, never once experienced a grade appropriate assignment during those 3 weeks. 4 out of 10 never once saw grade level work. That was true for only about 1 in 10 classrooms that served a majority of white students. That means that students of color saw assignments much more often that were not grade level than white students did. A lot of the time, we aren't even giving students the chance to demonstrate that they can meet the standards. So the schools that did provide students with the best classroom experiences tended to be ones that supported their teachers to be able to hold high expectations. These schools tended to share a few important traits. First, they had clear visions of what excellent instruction was expected to be like across all classrooms, and they focused on these instructional priorities consistently. But the best schools in our studies went further by pairing those clear instructional visions with strategic supports to ensure that teachers could meet those visions, put rigorous content and instruction in front of students, and expect that the students would be able to meet the demands of their state standards. For instance, administrators at these schools were frequently in classrooms in entirely non-evaluative roles, simply to offer teachers coaching and support to help teachers reach the vision that the school had set. They also tended to provide teachers with frequent opportunities to meet and think deeply about what the instructional materials and standards were that they were asking of their students, where their students were likely to have misconceptions, and how teachers would address those potential misconceptions without watering down rigor called for by the state standards and the instructional materials. By providing clear expectations and strategic supports aligned to these expectations, schools are supporting teachers to be able to hold high expectations for their students. So today, as I told you earlier, we're going to hone in on whether or not your students have strong instruction in math. And one natural question to have after hearing the first couple slides is, but how do I know that? So that's where we're going to dig in for the rest of this session. What are the hallmarks of excellent instruction? Putting grade level content in front of all students, asking students to do worthwhile standards aligned tasks with that content, ensuring students do the work and the thinking. There it is. So as we go through, I'm going to kick it back to Elizabeth, who is going to lead us down what this can and should look like in mathematics.
Thanks, Sharon. So what does this look like in a math classroom? TNTP has a tool that we are going to spend the majority of today on. So I'm going to ask Sharon to put that in the chat so that you have it. And I want to tell you a little bit about this tool, and then I'll give you some time to deeply dive into it. This is our instructional walkthrough tool for mathematics that we used in the opportunity myth research to determine whether students had access to effective instruction in math classrooms. So today we're going to orient you to this tool and talk about the high-level indicators here for effective math instruction. We won't be able to go over every indicator in detail. However, we will cover the tool so that you're able to use it in your school districts. We want to make sure that this session gets you set up to use this tool, and you might end up doing more norming with your team in Nebraska to really hone in on the specific components of this tool that would be most impactful for you. We think this will give you a general sense of what strong math instruction looks like so that you can develop your own vision of excellent instruction and either improve on your classroom practices or support others to be able to realize this vision of strong instruction. So what I want you to do now is take 2 to 3 minutes, read through the tool. So you're going to open it in the chat, make a copy so you have your own copy of the tool. And I want you to be diving into the tool for 3 minutes independently, taking notes and writing down any questions or things that jump out to you. So I'm going to set a timer for 3 minutes of independent time, and then we'll go into breakout rooms to discuss. All right, so we're going to go into breakout rooms just to have some time to debrief together. I want you to be asking questions about the tool and then also noticing things that jump out to you. So what questions do you have, and then what strikes you initially after reading through this? We're going to do just 4 minutes. I know that feels fast, but I want you to have time to talk and engage, but keep the pace moving so we get to all of our content today. So 4 minutes in breakout rooms to discuss questions and what jumps out to you. All right, it looks like we are back. Let's hear from 2 groups or 2 people who can share either a question or a noticing they're having about this tool. I'll go on mute and let you guys come off mute and share.
I know in our group, we talked about it. It's a great tool, like for a teacher, classroom teacher, to do collaborative planning with, to help make sure you're hitting all those areas, but not as much as like an evaluation, because sometimes you have to know a lot of math. And if you're not a person before you became a principal in math, it might be hard to know, are they meeting all these areas? Because maybe you don't really know. But like as a classroom teacher, this would be great to do planning with your collaborative with your partner.
I think something similar came out in our group too. And for math coaches or math leaders, it's a great tool. But if you don't know the content or the best practices of mathematics, if that's not your fluid language, it's more difficult to use.
Yeah, so I think that's a great two things I think you guys surfaced. One is like giving this to teachers, right? It shouldn't be a secret, like, oh, here are the things we're looking for. They don't know about them. So involving teachers, Lori, in the process can be helpful. So they know which components you're coming in to see. And even you may have noticed one key point for me is that it's structured hierarchically. So, you know, the foundational elements are at the top, that classroom culture piece first, and then looking for high quality mathematical content, moving into the practices of the teacher, and finally student ownership. So that if you're observing, you're looking for the foundational stuff first as you go along the route, the tool. So I think that can be helpful. But yes, like Lisa said, you are going to have some math content knowledge here and really understand some of these shifts we're trying to make in terms of implementing our high quality mathematical curriculums at a high level. And so that's our goal today, is to give you the tools that you need to be able to do that, and hopefully take that back to your team so that your team can implement that. Okay, so we'll start with the first section. In classrooms, we will start by looking at whether there's a culture of learning in the room, by which we mean, are students doing what is asked of them? We look at that first because if kids are not generally on task and focused during the work time of the lesson, then you may need to address classroom culture before you jump into the quality of the content or the thinking that's happening in the room. When we look at culture of learning, we're looking for indicators that students are doing what's asked of them in class. And we're also looking to see that students follow those behavioral norms and expectations, completing instructional tasks, and are generally focused on the work of the lesson. It's worth noting that in the research for the opportunity myth that TNTP conducted, most classrooms were generally on task and doing what was asked of them. The bigger problem, however, was that what kids were being asked to do was simply not as worthwhile. So overall, we saw culture of learning and engagement as a strong indicator. So I want you just to add to the chat, what is something that you expect to see in a math classroom that's meeting this culture of learning expectation? Can you think of a system or a behavioral expectation or a routine or a procedure that you might be looking for in that math classroom? And this may look different than an ELA classroom. So I really want to hone in here to what you might be looking for. I'll give you like 60 seconds just to brainstorm and then throw some things in the chat. Okay, I'm seeing conversations, discussing solutions, a safe place to risk sharing your ideas and strategies. That's really important and part of the culture that you need to develop. All students actively engaged.
Mathematical authority. I like it.
Okay. Great, still coming in. Willing to take risks and actively engaged in math. So in order for that culture to be in place, right, we want to see those systems and routines in place so that we can develop. So this is our first category. And ultimately you want to make sure you can check off these boxes. Another one that really stands out to me, and I've focused on a lot in my work with this rubric and this tool, is the joy of learning. So yes, showing risk and also sort of celebrating the successes that we have, finding joy and energy, even during these sort of socially distanced times or technology heavy times. How are we still making those connections and bringing that level of joy? And that is all included here in culture of learning. So once culture of learning, we then want to consider if students are working with math content that reflects the key instructional shifts articulated by the standards and infused in high quality instructional materials. So we are then looking for these shifts that are going to happen. The first shift is focus. Our instructional materials now, our high quality instructional materials, will significantly narrow the way time and energy is spent in the math classroom to focus deeply on that major work of the grade. And then we want to look at coherence. This is a connection across grade levels, so coherence from grade to grade, also within the grade from unit to unit, and even day to day in our work. And the last shift is rigor. This guides teachers to pursue balance between conceptual understanding, procedural skills and fluency, and application of those key concepts. If we don't do this, if we don't make math explicit for students and instead just teach them how to get the answer, they will struggle with the more advanced concepts and problems. So it's really key that we focus here. So what do we mean by these three instructional shifts, and why are we looking for them? Well, these are the main shifts that we're going to dive into today and really focus, it's one of the shifts, but focus our time on understanding these important shifts. And you'll see that these shifts show up in your Zern curriculum, in your illustrative math curriculum. So all of your high quality aligned instructional materials will reference these, and also our rubric and our tool will reference these. So we want to look for these, and I want you to think right now, we're going to do a poll, which is another way of sort of engaging you all in this process. And I want you to think, for the rest of 2020, 2021, where is your mind at? Where are you honing in your work around math? Are you really working to focus your teachers and your schools on the most essential math content? We've talked about that a lot with the Nebraska essential instructional content. Are you focused on coherence, making sure there's that vertical alignment and horizontal alignment within? Or rigor? Are you working with teachers on deepening conceptual understanding, not just procedure and fluency? So we'll open up a poll and we'll have you tell us sort of, where is your mind at right now? Which shift are you focused on?
We have 15 responses so far, looking for a few more. Thank you, thank you. All right, results are in.
Okay, Okay, awesome. Okay, so the majority of us, almost 60%, are focused here on rigor. That conceptual understanding balanced with the procedural skills and fluency and application, and how all three are going to be key to student success. So we will definitely dive in deep there, since we know that's going to be a big focus for the group. All three shifts will be important. So we're going to start with focus. This is the first indicator, and it describes a lesson that is focused on the depth of the grade level or the course that you're teaching, content standards. When you're observing for this indicator, you want to ask yourself two key questions. Does the lesson focus only on mathematics within the grade level standards? Does the lesson fully reflect the depth of these standards or parts of standards? The addition there of like parts of standards is important, because you may observe mathematical learning goals for a single lesson that don't fully cover the breadth of the standard. And we know that that's okay. In math, you are seeing a focused on grade level work that's aligned to part of the standard at an appropriate level of depth. You should still consider that lesson to be meeting our mathematical focus. It wouldn't be possible always on the first lesson to get the full breadth of the standard, but if they are aligned to a component of that standard, you would want to mark yes here. So historically, the US has tried to teach everything in a year of math. And you can see on this chart what that approach has looked like spread across grades K through 8. Each row in the chart is a math topic, like fractions or congruence. And you can see that several topics were taught every year in every grade level. This teach everything approach has not been effective. And when you look at American student performance on international math assessments, US performance lags behind that of students from many other countries. And what we see is higher performing countries actually focus on a few key math topics each year to build comprehension. And visually, this approach differs from the United States' historical approach. So here you can see sort of the United States approach with other countries. And you can see that this focus has allowed them to be much more successful. So this is the big shift that we want to make here. And our high quality instructional materials allow for this shift. In every unit, there's a deep, deep focus on that major work of the grade level. But since we've been teaching a while prior to these shifts, sometimes we want to throw in, a sort of smattering. We still want to teach a mile wide to make sure we've covered everything that students may need. So well-intentioned educators are still sort of teaching that mile wide and an inch deep mentality, when really the direction that Zern and other high quality curriculums is going is to teach an inch wide and sort of a mile deep, to go really deep into those conceptual understandings. Another tool that you can use here for math instructional focus, if you have follow-up questions or you want more information here, is the Achieve the Core work that they've done on sort of grade level major work. What is the major work for either grade bands or an individual grade level? And they have progression documents that allow you to see what you're doing in kindergarten and how that's going to impact 5th grade, and what you're doing in 3rd grade and how that's going to impact. So you can see the connections over time. You can also tell that, just 53% of observed math lessons focused on the right math content for the grade level. So that's only about half of those lessons where we saw that in play. This is what that major focus document looks like on Achieve the Core. Nebraska has adopted this as well. So there are places in Nebraska where you'll find this information. And those major clusters, the green boxes, are the places in each grade level that you're going to deeply, deeply focus. And so even within the grade level standards, right, there's some clusters that require greater emphasis than others based on the depth of those ideas or the time they might take to master. So those are going to be called the major work. So in 5th grade, in this example, you can see that place value, performing operations, fractions are the major work of the standard. And other components like analyzing patterns and relationships is an additional cluster that's going to support the major work, but isn't the essential content of the grade level. So those additional clusters support the major work and add complexity and add value to that major work. Ultimately, you want the majority of your time spent on the major work while still including and incorporating in those other clusters. And I think, you know, even if you're not using Common Core standards, the work you're doing with high quality instructional materials make tools like this really helpful. So although it might not be an exact crosswalk, these ideas can get you thinking about your major focuses for the year. Okay, so now we're going to dive into a little bit of practice. We want to see if this 3rd grade assignment focuses on the appropriate content for the grade level. So you're in a 3rd grade classroom. Just imagine you're there. The classroom is full of engaged 3rd graders. They have a great culture. You can just tell the teacher and the students have high energy. And the students are engaged in the math worksheet here. So how do we know if this lesson is focused on sort of the grade level standards or appropriate level of depth? Well, you would definitely need to know the standard. So the first step is to figure out what standard is the teacher targeting here. In this case, the teacher has 2 Nebraska standards on the board. Show and identify equivalent fractions using visual representations, including pictures, manipulatives, and number lines. And compare and order fractions having the same numerators or denominators using visual representations, comparison symbols, and verbal reasoning. So now you sort of identified the standards, they're on the board, they're in the pacing guide. These are the standards the teacher is focused on. Now, the next step is to determine, is what the students are being asked to do actually reflected in the expectations of the standards? So I want you to look at this for a second, take a screenshot if you need it, because I am going to put you in breakout rooms just to discuss, does this worksheet, does this activity address these standards, at least partially? Do you see this sort of addressing the major work here? So in 30 seconds, sort of zone in, read it really closely, take a screenshot if you need it. And Sharon will open up our breakout room so we can discuss. Does this focus on appropriate content for 3rd grade? Sharon, I think I'm going to go into the breakout room. So will you set a timer just for 4 minutes? Thanks.
Andy, welcome back. Oh, he might be in another meeting. I'm going to jump in a room.
All right, I think we're back. Seeing folks come back. Somehow my screen stopped sharing. I'm so sorry. I think it's because I went into a breakout room. Give me a thumbs up. Did that work? Okay, great. We're back. I was so caught up in my breakout rooms discussion. I didn't get back in time to share. I'm sorry. Let's hear. What do people think? Throw it in the chat. Do you think this is aligned to the standards? Is it focusing on the appropriate content for third grade? What did your breakout room decide?
Are you talking to me? Sorry, am I
Go
the
for
only-
it. Yeah, you can jump in.
Oh, okay. We decided no, there was a lot of just naked number computation here, or just really no focus on the process standards that are interwoven within all of our standards. And even if we were just looking at what the descriptions are in those indicators, it says that they need to use visual representations, including pictures, manipulatives, and number lines. Those are not there. It doesn't even give kids any kind of direction to make sure they're using those on this particular worksheet. And then again, on 311I, it talks about the visual representation. So there might be a place for some of these problems in their assignment, but this does not meet the standards.
And what do you mean, like some of these problems? Are there specific problems that you're like, even if they had sort of fraction tiles in front of them or some manipulative that was letting them do visual representation, are there some problems they still probably couldn't do?
I'm not sure I understand your question. I think that some of these problems would be acceptable to be in their independent work or their assignment, but not only these problems.
Got it. Got it. Yeah, I mean, I think when I look at this worksheet and think about third grade, you're right. You could give them a worksheet and visual representations or number line on a whiteboard number line that you're using. So there could be ways that they're doing the visual representations elsewhere, but you would probably give them 1/2 and 6/12. You would probably give them 1/3 and or 2/3 and 6/9. You probably wouldn't be giving them these bigger numbers like 36/45, right? That would be hard for a third grader to get all the tiles for on their desk. So when we're doing those visual representations in third grade, we're probably not going to be having numbers like 45, 50, 60 in the denominator. It might be too much to visually represent at this point in the lesson.
Yeah, you're right. We didn't even talk about that, but that's very true.
Yeah.
We just looked at it in general and said, no, this worksheet alone isn't going to cut it.
Yep. Yeah. And so I think, no, this worksheet isn't going to cut it. Exactly right. I heard that in the breakout room I joined as well. And also, even with visual representations or scaffolds, this worksheet still doesn't match. This worksheet is very procedural. To do this, you just have to know the procedure for multiplying to find equivalent fractions. And that actually comes in 4th grade. So someone in my group was like, oh, I'm in secondary math, but this doesn't look aligned to the standard. And she was exactly right. This is actually, asking kids to do that procedural step that they really master and do in 4th grade. And it ignores the conceptual pieces that we're expecting third graders to get. So I want to show you another example here. If we assume that this teacher had the same standards up, would this be an appropriate focus in third grade for fraction equivalence? So I won't do breakout rooms this time. I'll just have you spend about 60 seconds reading it, getting a sense of the assignment, and then we'll have a discussion. Would this meet our focus expectation in third grade? All right, that was 60 seconds. So I'll open it up to chat or just unmute and come off. What did you notice about this assignment, and does it meet the expectation of the standard or a portion of the standard? Tammy says this activity does a nice job addressing both standards.
Yeah, I would agree that I don't see anywhere where you're ordering fractions, but it certainly covers the rest of it pretty well.
Great. And that's where this component of the tool comes into play, where as long as it addresses a portion deeply of that standard, you can still give it a yes. What do you like about this assignment? What does it do that is addressing this really complex standard we have here? How does it do that?
It really opens up the problem for students by just saying show and identify equivalent fractions. and providing the visual for the students, they come up with as many as they want for each example. So there's no, blank equals blank. It's just very open to you to come up with as many ways as you want of how it could be represented.
Yeah, I really like that direction too, in as many ways as you can, because that allows me to enter at a low floor, but other students may help me see a higher ceiling.
And also too, when you're looking at it, it's showing you that you can represent in the pictures, like there's 3 of them that is really a half, but it's shown in different ways. And so it really makes them have to think a little bit differently. It doesn't have to just be all the top. Actually, there's 4 of them, not just 3. The top or the bottom, but they can be all interspersed as long as it's 3 out of 6. And so it really makes them think a little bit deeper.
And it's going to reveal misunderstandings if you have students that think B is the only way to show a half. Because I bet there are some that will think that.
So Lisa, that harkens back to our diagnostic session, right? Like this could then be diagnostic data that you use in a future lesson to address that misconception. So this idea of assessments that are giving you data that you can use, I think that's a great point. Like, oh, if you notice that misconception, then you can address that early. So you don't go weeks and weeks with kids having those misconceptions. It's awesome. Yeah, I pulled out the same things. I think it was all sort of covered in the discussion. So you guys are really sharp here at pulling out these key points. I had B, E, F, and G, right, are all representing that 1/2. So really hitting that home. And then you'd also have C and D, which is representing 1/3. So that would help in that regard too, just seeing those repetitive numbers come up, especially around key fractions like 1/3, 1/2, 1/4. Okay, awesome. So this is really what we would be looking for when we're going in with the lens of focus. So if that is your focus in your observation or while you're using the tool, these are the kinds of conversations your instructional leadership team would be having, staff doing walkthroughs for observations would be having. It's about exactly halfway through our session. So it's 4:31. I'm going to set a 3-minute sort of bio break, stretch break timer, not too long. So don't go away. There, I got a few folks back on camera. Thank you, Lisa. I see Lisa back. Drink in hand. Getting the group back together. Okay, so we'll give folks a few seconds to get back and we will head on to our next component, which is coherence. So next we look for evidence that the enacted lesson intentionally connects mathematical concepts within or across grades as appropriate, reflecting coherence from the standards. When you're observing for this indicator, when you're looking for coherence, you're going to ask yourself 2 key questions. Does the lesson explicitly build on students' prior understandings or lay the foundation for future learning? And does the teacher take advantage of opportunities to make connections to the major work of their grade? So throughout the lesson, are they making those connections? Teachers make those explicit connections in a variety of ways. So this isn't about sort of what strategy the teacher is using. The emphasis here should be that you observe evidence that an explicit connection has been made that will support students in making a connection to prior or future mathematics. So before we had high quality instructional materials and before we made these shifts in our mathematical thinking as a nation, math was taught as a discrete list of skills without making coherent progression a priority. As a result, students did not develop a deep understanding of connections between math and skills. Instead, they saw math as a list that they were just checking off. In second grade, the teachers and the kids were checking off mastery of those unrelated ideas and procedural skills. And in third grade, they were checking them off again. Teachers did not think about math across grade levels or even link major topics within a grade. And each standard was taught as a new event, not as an extension of previous learning. This resulted in teachers teaching the same content year in and year out, and it undermines students' sense making in mathematics. In some places, you might still feel like you have this checklist style teaching in math, but if you adopt a high quality instructional program like Zern or illustrative math, it'll help streamline content and provide that coherence for you at each grade level and within grade levels. For example, now students are going to develop a strong foundation in numbers and operations before we ever introduce fractions. So in grades K2, students develop proficiency with operations using whole numbers. Then in grades 3-5, the students apply this understanding to the operations with fractions. So each new standard isn't a new event, but an extension of previous learning. And in high quality instructional curriculums, you'll see that progression build, and teachers are able to reference the work that students did the year before, or the work students did the unit before, that's building on itself. So here are 3 examples of coherence in practice. When we talk about coherence, we're thinking year to year. Is grade level content building on itself? So an example would be in 3rd grade, you would say, or in 4th grade, you would say, in 3rd grade, you learned how to add and subtract fractions with the same denominator. This year, we will learn how to add and subtract fractions with different denominators. Let's start with what we know, so that students are grounded in that 3rd grade knowledge of like denominators before you move them into the new conceptual understanding of unlike. Between units, we want our units to be sequenced to build on each other over the course of the school year. And within that, teachers would make connections from unit to unit. Last unit, we studied linear expressions between 2 quantities. This unit, we will begin to discuss what happens when there is not a constant rate of change. So this switch from linear to nonlinear. And then finally, day to day. Teachers and students make connections and build on what they learned from previous lessons. So ensuring that our curriculums are building over time. Over the past few days, we have been studying complex fractions, their meaning, and comparing numbers. Yesterday, we used modeling. Today, we will continue to model, right? So making these connections from day to day. So now we're going to jump into our idea here around rigor. This is our 3rd instructional focus, and it is also the one that 11 of us really want to work on this year. So we'll spend a meaty portion of our time together here. Here we're trying to balance conceptual understanding, procedural skill and fluency, and application. So when you are observing for this indicator, when you're looking for rigor, you're going to ask yourself 3 questions this time. Which aspect of rigor is called for by the standard being addressed? Standards are written with an aspect of rigor in mind. So you'll want to know, what is the standard and what should I be seeing? Which aspect of rigor should this lesson include? Which aspect of rigor is being addressed by instruction? So how is the teacher teaching that lesson? And do those match? So is the teacher teaching the level of rigor the standard calls for? If the lesson is focused on an aspect of rigor other than that addressed in the standard, you should indicate no to this indicator. Oops. So what do we mean by rigor? This is often depicted or described as a three-legged stool. Each of the three aspects is critical and needs to be addressed for students to be able to reach the depth of learning that's expected of them in the standards. So without any one leg, this stool and the person on it would topple over. We need conceptual understanding. That's that deeper learning of the how and the why. But we still need procedural skill and fluency. These shifts aren't saying never teach the standard algorithm for multiplication or division. Students need to know sort of their procedural skills and to fluently be able to do operations. But they must have that conceptual understanding before they jump into procedural skills. And then application. Can students apply the knowledge that they have, this conceptual understanding and those procedural skills to tackle real world problems? These three aspects can work together to create deep, authentic command of mathematical concepts. Students develop conceptual understanding of math concepts so that they are able to see math as more than a set of mnemonic or discrete procedures. So, we don't just want them to be thinking of all of these tips and tricks that we probably learned when we were in school. We want them to have the conceptual understanding of how they got that answer, of the deeper math behind those processes. Students do need those to develop skills and fluently solve problems as well. So there could be time dedicated to procedural skill and fluency within your lesson. You want to see those components. Students definitely need to have those as a core piece of their instruction. And then application. Students are going to develop their application skills so they can choose and use the appropriate concepts and procedures when they are tackling a tough mathematical challenge in the real world. So providing them chances to apply their knowledge will allow them to be more successful in high school and college and in their careers. So I want you to look at some sample math problems. Here we're looking at 2 8th grade problems from international assessments. This is from Trends in International Math and Science Study. It's an assessment we give internationally. Students here tended to do pretty well on the first problem, but not so well on the second one. So I'm going to give you some time to dive in, read the problem, solve the problem, and think, why are students able to master this first problem, and that yet we're seeing such low mastery of the second problem? I'm going to give you 90 seconds independently, and then we will talk amongst in our big group. So we'll stay big group. About 30 more seconds. If you're still focused on problem 1, move over to problem 2 so you can really deeply understand that. All right. Why do you think students were able to show mastery here of this first problem? What made this problem something here that students could solve?
They could actually use like M and N and actually put real numbers in there and then try to figure out how many total balloons and then go and figure out which expression actually goes with their answer.
Okay, great.
This was a
To
real
me, it's an
concrete,
easily, sorry, Jenny, go ahead.
that's okay. I saw this as a really concrete example that they're boys and girls, they could see that, they could see balloons, everything could be imagined in their mind. It wasn't very abstract. So I saw this as very concrete for them to figure out.
I also saw it as very easily reproducible, a common problem type that they've seen since third grade.
Yeah, I mean, also they were given all the necessary information and no extraneous information, right? It's all right there for them. It's very procedural in nature, right? This is a procedural problem that they're being asked to do. There's very little sort of application. Like we said, it's not as rigorous. So this is overwhelmingly something students were able to succeed on. And now look at this second problem. What do you think lends itself here to students having such difficulty? What did you notice might trip them up?
The first thing I thought of is that someone along the way has told them that whenever you multiply numbers, you're going to get a bigger number.
Mm-hmm. So what's the common misconception going to be here? If we had to guess, what do you guess most students picked?
And A.
A, overwhelmingly, I would bet. Yeah.
Also too, they don't understand how to look at a number line here. And even though that they're not marked, you can see where P is and tell what that number is. So you can estimate what Q is. And then they could use their procedural skills to multiply those fractions to find your answer. But they might lack that knowledge to look at P, and P looks like right middle half.
Mm-hmm.
And if you know that, then you would know, okay, Q is more like 2/3. And then they could break it down so they would know A and B would not be the answer.
Mm-hmm.
But they may lack that skill of actually locating a fraction on a number line without hash marks.
Mm-hmm.
That conceptual part.
It's
Exactly.
the opposite of all the things that you said before, about how it was a procedural problem. This is an application problem. They're taking something that they've learned and they're having to apply it in this kind of new and unfamiliar situation.
Yeah.
Which can be difficult. And so it's abstract as opposed to the concrete.
And I would say that this is conceptual as well. When I was looking at it, I think it's less procedural and more conceptual because they have to conceptually understand this big misconception someone brought up, that multiplying two fractions less than one will result in a product that is smaller than both of the factors, right? Like they have to understand that. And I think the first person said, oh, multiply, get a bigger number. And that concept, if not taught, is something they wouldn't be able to grasp, even if there were more words or more context, right? They're still going to be missing that conceptual understanding.
So just to add a little bit to that, I think something that as we try to write assessments more like the one that got 22% accuracy, I think one of the challenges is as soon as that becomes proceduralized in a classroom, then it's no longer conceptual understanding. If I've, as a student, have seen a similar problem to that 10 times in class, then I sit down and take the test and I just know that if my P and Q are above 1, it's bigger, and if it's below 1, they get smaller.
Mm-hmm.
Then it becomes procedure. So it's hard, and it's part of the agreement that we have to have with teachers of this is what we're trying to assess. It doesn't mean you give them 5 of these sample problems before the assessment happens.
Mm-hmm. And I think And I think this is where the high quality instructional materials come in, and like a plug for curriculums that are designed to do this. You know, if you use Eureka or Zern, you'll notice that the problems that you're doing in the problem set and all class sometimes look different from the assessment. And sometimes teachers at first are like, this isn't the same problem. I need to make 5 of these and do them for guided practice before they take the assessment. The mid-module assessment is too hard. And they're missing this point, right? To your point, they're missing the key shift we're trying to make, which is students have to be able to gain conceptual understanding and then apply that in different contexts. And if we do this, where we take a problem and make 5 replicas and teach those 5 and then give them the assessment, we're holding our kids back. And so if you see that, you should mark that low on this instructional tool and give that teacher the feedback that even though they think they're helping them reach mastery, in the long run, they're going to hold them back from those conceptual understandings.
Is this a weakness of the multiple choice test though? That in order to see what kids truly understand, they need to show us in a different way versus multiple choice?
Yeah, I think that definitely could be feedback here. And I'm sure there are other questions that are like select all that apply or short answer or solve that could get deeper. But I think this is a nice comparison of 2 multiple choice questions that show us this gap between procedural skills and sort of conceptual understanding. All right, great discussion. I'm going to keep us moving unless there's any last words here.
Can I just ask for clarification then, when we're looking at rigor and there's the 3 aspects, the 3 stools, are we saying that perhaps procedural is a lower rigor than conceptual and application then? And then is there a true hierarchy that we look at that?
I don't think there's a hierarchy, and I wouldn't want to say procedural and fluency are not equally important. I would say they're all equally important, but I would say there might be an order to which you're teaching. So you should ensure that kids understand the conceptual understandings before you give them those procedural tools to solve a problem. So there could be an order that matters, but I wouldn't necessarily say that one is more important. And in high quality curriculums, you'll see that the time is spent equally amongst all 3. So usually some curriculums will start with an application problem. We'll start students thinking with those application problems and allow for productive struggle before you jump into the concept development piece. And then once they understand the concept, once you're able to get students to name that 2 fractions less than 1 multiplied together, once you were able to get them to name that statement, then you can teach them the procedural skills. They need to do that fluently and quickly. Would anyone else want to add to that answer?
Like, since we're sort of thinking about this instructional walkthrough tool, I don't know that you would regularly see rigor, all 3 legs of the stool represented in every lesson, right? You may have a couple of days of developing the concepts. And so when you're going in there, you're like, well, you didn't actually have rigor because you didn't ever get to procedural fluency, which I think is okay. It's just, we all know teachers and they get really mad when they're not yet on their walkthrough tool. So.
And I would agree with that, Josh, as when administrators go into build classrooms, that sometimes they're in there for 20, 30 minutes and they're just seeing a small snapshot. And when our administrators don't know the process that the learning needs to happen, that they too might not be able to assess a teacher's level of what they're doing or where they're at. The teacher needs to be able to explain that. But in a quick walkthrough, that's hard to do.
Yeah, I think you're right. I want to add one key thing here about rigor that I think might help clarify that question. And it's identifying the appropriate aspect of rigor you should see. That actually should come from the standard and the language of the standard. So there is a right or wrong answer to what you're seeing at a time. So if you're in a room for 20 or 30 minutes, you want to see the majority of that lesson focus on the aspect of rigor that's written into the standard. And so language here in the standard is going to matter. Language that talks about understanding, explaining, interpreting, recognizing is trying to get at conceptual understandings. Fluently add, subtract, multiply, divide, solve, find is going to give you procedural skill and fluency. And application will usually include a term like real world problems, design, develop, or apply. So when you're walking into a classroom and you're identifying the standard, that should help you identify the level of the aspect of rigor you're looking for. Some standards have multiple aspects. So it could be conceptual and procedural. And in that case, you might see 20 minutes just focusing on conceptual, and you would want to give them credit for that. Or you may see it just focused on procedural. And I would caution you, if they're only focused on procedural, to make sure that you ask a student or you check that there's evidence that they also did the conceptual piece before that. So I took 3 standards from Nebraska, again, looking at 8th grade, felt like a good grade to try to model this. The first standard, explain a model of the Pythagorean theorem, is going to focus more on conceptual understanding. Students should be explaining their thinking using models. A procedural skill here, standard would be find the distance between any 2 points on the coordinate plane using the Pythagorean theorem. They're telling them what to use and how to find the distance between 2 points. That's a procedural skill that kids need to fluently be able to do. And then for application, apply the Pythagorean theorem to find side lengths of triangles and to solve real world problems. So depending on what standard is being taught in 8th grade math, you are going to be looking for a different aspect of rigor when you go in. So you should not be looking for all 3 in every lesson. If I want to clarify that misconception, if I stated that, you do want to look for the specific aspect of rigor that the standard calls for. And I'm going to show you a tool that I think can be helpful in this work. I know it's not exactly aligned to Nebraska standards, so I did this alignment myself for the Nebraska standards. But this tool from Louisiana the state of Louisiana has identified the level or the aspect of rigor in every standard in Louisiana. And so you can actually go onto their website and find this tool. It's called Guide to Rigor in Mathematics. And it has already identified the aspect of rigor for every standard. And you'll see here, some of them are 2 aspects of rigor. Some of them might be just 1. Some of them could include all 3. And so this can help you if you want to gut check yourself. Oh, how did I do in identifying that standard? Let me find a similar Louisiana standard and check what aspect of rigor the state of Louisiana picked. So I think this is a tool that you can use, and it could sort of guide your thinking about this work in Nebraska. So I want you to practice. In terms of time, I just want you to look at the top standard in dark blue, which is sort of this overarching standard in 5th grade in Nebraska. Students will demonstrate, represent, and show relationships among whole numbers, fractions, and decimals within the base 10 number system. Which aspect of rigor would you be looking for if you went into this classroom? Which aspect of rigor? When you think you know, throw it in the chat so we can check where we're at and then keep moving. Great. This is asking for conceptual understanding. I think you can pick out some keywords here, like demonstrate, represent, the relationships between. So conceptual understanding. Next, we are going to look and see if the teacher's instructional practices support all students to learn the content of the lesson at the depth intended by the standards. So we're moving on to sort of the teacher's instructional practices here. We want to see indicators that the teacher is making the mathematics of the lesson explicit for students so that the class discussion is focused on the mathematical concepts involved and not simply on how to get the answer, and that the students have the time and opportunities to work on grade level appropriate mathematics. From there, we want to see that students' solutions and ways of thinking are shared and discussed in the class, and that those solutions or ways of thinking are used to strengthen other students' understanding of the concept. Teachers should deliberately check for understanding throughout the lesson by posing questions that will make students' current understanding or current misconceptions about the math visible, so that we can address those misconceptions or highlight the understanding students have. And finally, teachers should facilitate a summary of the key understandings from the lesson with reference to student-generated solutions or discussions to sort of reinforce the math at the end of the lesson. So what this might look like is a challenge here we might see is if a teacher is teaching this butterfly method, which is how I learned how to add fractions here, they are not making math explicit for the student. They are not teaching that student the concepts here. It's just how to get the answer, and that student is going to struggle. So if you teach the butterfly method and then on the assessment, there's a problem that asks you to add 3 fractions, that student's going to say, well, now what? How do I do the butterfly method with that 3rd fraction? How can I solve this type of problem? So we really want to focus on the understandings and not tips and tricks that get students an answer without really truly understanding the material. So how are we going to do that? Students conceptualize mathematical concepts in many different ways. They're all appropriate. At nearly every moment in nearly every class, we know that many students aren't processing content in the exact same way that the teacher is processing the content. For example, when a teacher references 3/4, she may be visualizing this 3/4, right? As a sort of her visual, like 3 out of 4 slices of pizza, right? That might be what the teacher is saying. But students might be thinking of quarters. 75 cents is 3 out of 4 quarters. Another student may see, 3 red balloons, or another student may see 3/4 of an inch on a ruler and be visualizing something different. So we want to keep in mind that effective instruction here would recognize that students conceptualize mathematics in different but equally appropriate ways. And we would have avenues and access points for multiple ways of conceptualizing math so that students can strengthen their understanding of the concept at hand. And then finally, we would look to see if students exhibit these key mathematical habits of mind that they need to be prepared for college. This is the student ownership piece. It's last on the rubric. And it means sort of you have to have those other components in place for this to go well. So sometimes we really focus here, but if teachers haven't done the key work necessary, students won't be successful here. So this is the place that we're going to focus. The last little bit of our time together, which is we're going to watch, we're going to watch about 12 minutes of a teaching video. And I want you to pull up, so have your screen, pull up the instructional tool from TNTP on half of your screen. And I'm going to have the video playing on the Zoom half. And I want you to actually go through and evaluate this class for 12 minutes on the instructional tool. Where would you put this? What are you seeing and hearing? And then we will come back together, do a quick little breakout room so you can discuss, and then come back together and wrap up. So the link just went back in for the tool. If you joined late or you left and you need access to it again, click on that link so you have the tool up. Get your computer screen set up, and then take notes, annotate that form for yourself. That's your own copy to determine where she's meeting the demands outlined in our observation protocol.
So today we're going to actually start learning Target 5 using our understandings of multiplication and division to divide fractions by fractions. So today the lesson was about having students tap into what they already know about multiplying and dividing whole numbers and multiplying fractions to begin to learn how to divide with fractions. What was the big idea that we learned when we multiply fractions? What happens to the product when we multiply fractions?
I was gonna say that it cuts in half most of the time.
So let's look back here up at this big idea. Multiplying by a fraction less than 1. Is 1/2 less than 1? Yes. Yeah. And when we get 8 times a half, what do we get? 4. Is the product less than one of the factors? Yes. And then what happens when we take, which is kind of similar to what you were talking about, this halving idea. It's halves one of the factors. When we multiply 1/3 times 1/4, what do we get? 1. Is the product less than both factors? Yes. So I want you to keep that in mind today as we start dividing fractions. And instead of using the language of factor and product, we're going to be looking at the language of dividend, divisor, and quotient. So today I want you to be thinking, what happens to the quotient when we divide by fractions? When you look at the standards and how they're written, the division standard is actually quite complex. It's not just a simple students learn how to use the algorithm to divide fractions, which is what we might see in some of the former state standards that are out there. But if you actually look at it and think about it, students need to understand and interpret the quotient very clearly, that it is larger than the dividend and the divisor. I want you to silently think to yourself and solve to yourself this problem. And even if you're not sure, that's okay, because that's what we're going to do today. We're going to figure out how to solve problems like this. All right, go ahead and turn to your partner. What do you think the answer is to 3 divided by 1/2?
1.5. It's 1.5 because a half of 3, a half of 2 equals a half, and then a half, well, no. A half of 2 is 1, and a half of 1 is 1/2. Yeah, so if you add those two, you get 1.5, which is half of 3. Yeah.
What were some of the answers that we had? What were some of the answers, Alondra?
1 and 1/2.
So one of our possible solutions is 1 and 1/2. Marlene? 6. Any others out there? Jesus?
I got 1 and 1/2.
Great. That one's already up here. Any others? All right, so we have 2 answers. These answers are quite different from one another. So now what we're going to do is we're going to try to make sense of this. Is there somebody who'd be willing to share their thinking about how they got 1.5 or how they got 6?
I divided 3 divided by 1/2, and I knew that half of 3 was 1 whole and 1/2.
Okay, so you thought of 1/2 of 3 is 1.5?
Yeah.
Okay, and let's hear from another.
I don't know what the answer is, but I don't think it's 1 and 1/2 because 3 times 1/2 equals 1 and 1/2, and we're dividing.
Interesting. So let me get a different color here. So you are saying that 3 times 1/2 equals 1 and 1/2. Okay. Turn and talk to your partner. What do you think about this statement? Is this true?
We're dividing and not multiplying. times 1/2 is true because 1/2 3 times is 1/2 plus 1/2 equals 1 plus 1/2 equals 1 and 1/2.
I had did the division algorithm for the problem, and I ended up getting 2. So I'm actually agreeing with Annabelle that it might not be 1 and 1/2.
Okay, so you're not sure this is the correct solution, but you're also not sure what it might be. And it sounds like you've learned some sort of a procedure for dividing fractions,
Yes,
but you're not sure. You're confident with it or not sure?
I'm confident.
You're confident. Okay, so you think the answer is 2. Okay.
I remember that division means groups of. So they're trying to find how many halves are in 3, and that's 6.
So I'm looking 3 into groups of 1/2. Okay. Or I could say 3 into 1/2 parts. And you're saying that's 6.
Yeah, because one there's 2 halves. 2 halves. So in 3 there's 6. Because the people that are saying it would be 1 and 1/2, that would be multiplication, but we're talking about division.
So you're saying that a multiplication problem and a division problem can't have the same answer?
Because, well, sometimes they can, but like in this case, because it's saying that 3 times 1/2 does equal 1 and 1/2, but I don't think that 3 divided by 1/2 equals 1 and 1/2.
The best part of the lesson today was listening to the students think about making sense of this problem, 3 divided by 1/2, and being so convinced that it was 1 1/2, which was incorrect, and trying so hard to come up with evidence for why they felt so strongly that 1 1/2 was the solution. There was the great moment when a few kids said, well, I know it's not 1 1/2 because if you multiply 1 1/2 times 1/2, you don't get 3, and multiplication is a check of division. So I loved hearing that. What I want to do right now is talk about what mathematicians do when they are trying to make sense of a problem. We're trying to make sense of 3 divided by 1/2, and we have 2 ideas. Most of us are saying 1 1/2. Some of us are saying it's not 1 1/2, but I'm not sure what it is. And then we've got some of you that are saying it's 6. So is this our problem? All right. So I'm going to take out our fraction kit pieces. So we're going to try to make sense of this problem by, let's model. So if we were to do 3 into groups of 1/2, by looking at this model, I want you to look at this model and talk to your partner. 3 into groups of 1/2. How does this model help support your idea or change your idea?
What the model that you put supports my answer because 6 is also the answer, but it's because it's like how many B's go into A, and
hang on. How many B's go into A? What division statement is that? Number 2. How many B's go into A? Okay, so keep talking.
So I just put like how many halves go into 3, and I got 6. I would like to agree with my answer, which is 1 and 1/2, because if you we're dividing 3 into like its half, so it would be 1 and 1/2 if you cut that in half.
Okay, so is this problem 3 divided by 2? You're saying this is what we're doing?
Sort of.
Sort of. So you're saying that these 2 would have the same answer? Yesterday, we agreed that all 10 of these statements were true. That you could model a division statement by thinking of the dividend as A, the divisor as B, and you could ask yourself how many B's, how many divisors go into A. So if we use what Clinton said, this would be our B, and this would be our A. How many B's go into A? Does this make sense? 1, 2, 3, 4, 5, 6? Yes. Makes sense. So that whole moment of dissonance and disequilibrium around 3 divided by 1/2, which took 10, 15 minutes, was so great in hearing so many kids share their thinking and try to prove their idea and their answer with evidence. So I was thinking about what's long that we could divide? And then I was thinking, well, candy, it's Halloween's coming up. So I was envisioning licorice, although would you believe it, licorice is the only candy that I actually don't like. But it works for this model. Imagine we have a long rope of licorice. It's 2 feet long. And I want to divide, Ismail and Brian, I want to divide this rope of licorice into 1/6 of a foot pieces. So my question for you is, how many pieces of licorice will I have if I divide it into 1/6 pieces? And to do this, I'm going to give you a fraction kit for you and your partner to see if you can make sense of this problem with a model. And what I love about the Common Core in math, particularly the mathematical practices. And so for me, I feel like they have unleashed this new excitement around teaching when I'm really starting to think about not just students mastering skills, but mastering ways of thinking and thinking about how do I measure kids' ability to use models and make sense and critique the reasoning of others. So I feel like for me, it's expanded all the possibilities of what I can do with my lesson planning, and just it's challenging. So I checked in with most all of the tables except for this table. So I'm going to actually go to this table. How many pieces of licorice did you guys decide I would have? Angie? 12. And how did you figure that out?
Because like there's 6 on this side, and then we put 3 1/3 instead of the 6, and then it also equals 6, and 6 plus 6 equals 12.
Ah, okay. I want you to now go back to our problem, and I want you to put 3. I want you to put 3 pieces of licorice. Now your rope is 3 feet long. So go ahead and put 3 blues in the center of your table so everybody can see. And this time I want you to divide it into 1/2 pieces. 1/2 pieces. 1/2 pieces.
Each one. If you do 2 times 3, that's gonna give you 6. That's gonna be 6 because like 4, 6. Because 2 1/2 equals 1 whole. So how many halves go into 3? 6 of them. So 6 is gonna be the answer.
So are we convinced now that 3 divided by 1/2 is actually 6? Yes. All right. So here's what we're going to do now. Now I'm going to mix it up one more time. We're going to do one more problem together, and then I'm going to give you a chance to practice. And the problem that I want you to do now is 1/2 divided by, imagine I had 1/2 foot of licorice. I have 1/2 foot of licorice.
All right, we're going to pause there, and we are going to go into breakout rooms now. We've watched the video. We have our instructional tool up, and I just want you to debrief with your group. Where are you going to rank this? What are your thoughts? Where are you seeing the aspects of rigor? Where are you seeing these different instructional strategies? Or what aren't you seeing that you want to see more of? So we'll go to our breakout rooms for just 4 minutes so we can come back together and wrap up by 5:30. So 4 minutes in our breakout rooms to dive in and discuss. All right, looks like we've got most folks back. I heard some great discussion in the breakout room I hopped into. But let's just dig in, and we'll go through as much as we can. Culture of learning, give me a thumbs up, thumbs to the side, thumbs down. How do you think it was? Okay, see. Thumbs up, yes, great. So we've met that first criteria. So anytime you go in a room, you're looking there and before you move on. High quality mathematical content. Focus. This was definitely focused on 6th grade standards. It also referenced the 5th grade standards of sort of dividing whole numbers by unit fractions. So she was focused. Coherence, yes, right? The teacher started with problems that students were exposed to in 5th grade and then dove into the 6th grade level work. So she's, recalling that prior knowledge so that students can be successful here. Additionally, they were also doing some within grade coherence. They started by talking about multiplication and then developing that into division. So they did a quick review of some of their multiplication conceptual understandings before jumping into division. And then rigor, again, this was targeting the aspect of rigor conceptual understanding called for by the standard. It also calls for procedural skill. So this standard calls for conceptual understanding and procedural skill. And what we saw was primarily conceptual understanding. But this is because it's the introduction. This is the first time they're getting into this. So we want to see more conceptual understanding. And by the end of this unit, we would expect to see more procedural work around this standard. So there, for that section, I would give an overall rating of yes, and also for focus, coherence, and rigor, all of the components have a yes. High quality instructional practices. Someone come off mute. Where did you rank her here? Where did you rank her here? What were your thoughts?
We had a conversation in our group about, was there anything that we didn't see? And we decided, we had the conversation about, we would have marked yes on all of the component, or, the 4 questions that were there, that yes, we saw them, but what would we say if this teacher came to us and said, thanks for that feedback. Yes, yes, yes. I know I'm great, but what can I work on? And so we said that if there was a feedback that we would give the teacher for improvement, it would be around the student to student conversations versus the student to teacher conversations, because that's what we couldn't see as much. And I don't know if it's part of the video or if that was just lacking, but especially it looks like there might be some English learners in the classroom. And are we using those sentence stems to help them verbalize their own thinking versus her asking the question, but kind of her being the one processing the actual thoughts?
Great. So yes, but you also identified maybe one area to work on. I would agree with you. Like, we hit all the boxes, but of course there's areas for growth. Similarly, in student ownership, I would say, like, mostly here, there were some places where the teacher did more guiding than we would want to see, especially around what tool or strategy to use. So she picked the sort of, what was it? The fraction pieces. She gave them that strategy to use, and it limited their thinking to just the strategy she provided. So there could be a way in some of this work where students are choosing from a menu of strategies or approaching the work differently, so then you can discuss those strategies. So again, overall, like, a lot of yeses, really positive, but we can identify places for growth within that. Awesome. So to wrap up, we're gonna leave you with these same questions we started with. Do you have a clear vision of excellent instruction for your schools? If asked, would your teachers articulate the same vision? Does your definition encompass the key indicators of great instruction discussed today? Put grade level content in front of all students, have students focus on standards aligned tasks, and ensure students do the work and the thinking. If you answered no to any of those questions, you will likely want to work on your vision. And we hope that this instructional tool can help you narrow down your focus and really guide your work in the upcoming quarter and the upcoming year while you're planning for high quality math. That's it for us. I'm gonna go to the end of our slideshow. You can go to TNTP and find the opportunity myth. They have some resources there for teachers and for school districts. We will share out this PowerPoint as well as the recording, so that if you want to dive deeper, you can. And it also has a link to the video in case you want to reuse that video in future PDs. Thank you guys so much. You are amazing. I know it's 5:30 on a Thursday. Monday. What day is it? 5:30 on a Monday. Thursday. Come back on Thursday. We'll be here again. 5:30 on a Monday. Really appreciate your time, your participation, and your energy. And I hope this tool can be helpful to you. Bye, guys.
Thank you.
Thank you.
Thank you.
Bye, thank you.
Oh, sorry, my video was glitchy. Sorry.
That's okay. I don't know if it was you or if it was